Hey everybody, this is Mr. Piercy, and what we're going to be looking at in this video are different ways of classifying numbers using set notation. So there's several different ways that we've classified numbers in math, kind of like the way we classify organisms in biology. We have characteristics that they have in common, so certain things will overlap, but diverging characteristics will create new categories that we use to classify numbers. So the numbers that we begin with are what we would refer to as natural numbers. Natural numbers are kind of denoted with this capital letter N here to indicate that we're talking about natural numbers. Those are typically what we think of as the counting numbers. 1, 2, 3, 4, 5. They have to be positive whole numbers. The next set of number sets that we're going to be looking at is something called whole numbers, which is going to be this capital W that you see here, indicating that we have whole numbers. Now, the only thing that separates whole numbers from natural numbers is the fact that whole numbers includes the number 0. You and I may consider 0 as an intuitive thing because we've been using 0 for so long, but 0 was a number that actually had to be proved that it existed, and it didn't exist for a long time. So that's the big difference between natural numbers and whole numbers, is they're still positive whole numbers, but the whole number set will include the number 0. Moving on, we're going to include integers. Integers are going to be denoted with this Z here, and again, we don't really want to use I too often when we're talking about things in math, because I is often considered to be something that's reserved for imaginary numbers. J is sometimes used for imaginary numbers in electrical systems. But anyway, integers are going to be whole numbers. However, they can be positive or negative. So this is where we would expand our number line, going back to, like, say, 3rd or 4th grade, when we expand our number line to be not just from 0 counting to the positive side on the right side of 0, but also to the left side of 0. But we're only counting in whole number intervals. So -1, -2, -3, those are considered integers. So whole numbers are made up of natural numbers, and integers are also made up of natural numbers. So all of the natural numbers so far have been included in these things. However, as you can see, integers, they're not all going to be whole numbers, because negative numbers are not part of the whole number set or natural number set. Next, we're moving on to rational numbers. Rational numbers are going to be noted with this letter Q. Now, all of this stuff that you see here in the brackets, that's kind of a mathy thing. Here, this is a symbol for the word element, and of course this is not equal to. Well, rational numbers are going to be numbers that, this is where we start including fractions or decimals. Rational numbers can be fractions or decimals that would be from, say, 1/4 or 0.75. Those would be considered rational numbers, because those are going to have decimal numbers that terminate. We can also include rational numbers as rational numbers that would have a repeating decimal, so like 1/3 or 0.66666 repeating. Those would be considered rational numbers. So rational numbers, starting where we're getting into fractions that can give us numbers that terminate, or like 0.25, 0.75, and things like that, or fractions that repeat forever, so like 1/3, 2/3, etc.